Assalamualaikum and good day. My name is Farhaana Athirah binti RAHMAN. Today I would like to present to you my review paper in the title of A Review on the Effect of Changes in Salinity on the Acclimatization of Freshwater Rotifer, Brachionus calyciflorus. I begin my presentation with the background of study. So what is rotifer? In general, rotifers are confined mainly to freshwater. Salinity therefore plays a vital role in the diversity, survival, and reproductive capacity of an individual rotifer. Rotifers are used as the first feed for fish and crustaceans when they were in larval stages. Several species at the early larval stages cannot consume certain sources because of their mouth opening are very small. Therefore, B. calyciflorus can be used to replace the large food sources for the species at early larval stages. The species of B. calyciflorus also is more prevalent at lower salinities. In the modern aquaculture, there are several challenges that need to be addressed, and one of the major challenges is to achieve the diversification of aquaculture industry. Therefore, the species of freshwater rotifer need to survive in a suitable salinity in order to achieve the great diversity of aquaculture industry. There is also a lack of current studies on the culture of freshwater rotifer in different salinities. Most of the studies that were found are usually regarding changes in salinities of the seawater rotifer. The additional of the study in the culture of rotifer species in different salinities, it could bring a recent and up-to-date actualities in order to create a new potential to increase knowledge in the study of B. calyciflorus species. This is because there is either absence of current studies or lack in recent studies. Other than that, we managed to learn the species of freshwater rotifer and how it can survive and acclimatize in a suitable salinity in order to achieve the great diversity of aquaculture industry. Here are the three objectives of the study. The first one is to study the morphology and taxonomy of B. calyciflorus species. Next, to determine whether B. calyciflorus species can acclimatize with higher salinity and how it differs with seawater's adaptation to salinity changes. And the third one is to indicate the factors involved in lower salinity tolerance of freshwater rotifer. According to Gilbert 2018, the rotifer B. calyciflorus is a small, approximately 200 micrometers metazoan that is common and quite frequently abundant in nutrient-rich freshwaters in zooplankton communities. Arimoro 2006 stated that rotifer's body is covered by a cuticle, bilateral symmetrical and sexual dimorphism, as is in the species. Monogonanta is the largest group for the phylum Rotifera, and B. calyciflorus is one of the species in Monogonanta according to Seger 2007. Normally, when the environmental conditions are suitable, female rotifers produce up to 7 eggs simultaneously without any genetically similar and hatch to form new daughter rotifers. Moving on to the culture method. For freshwater rotifer, continuous culture and batch culture method can be applied. For the continuous culture, it is a culture that requires a continuous supply of cell suspension or the product of medium. For batch culture method, it can be defined as by transfer small portion of culture into a new culture which gives result in growth and increase in biomass. Next, the presence and abundance of rotifers depends on both abiotic and also biotic factors and changes in environmental condition. Salinity can contribute to differences in the physical environment affecting the process of ecosystem. The impact of salinity is directly linked to the osmotic regulation of an individual, which in turn is highly reliant on the genotype and the species. Increased salinity of water causes changes in rotifer populations and affects their diversity and dynamics. For your information, investigations on the impacts of salinity changes on rotifers are mainly reported from few euhyaline species such as B. rotundiformis and B. plicatilis, but only little details is available on B. calyciflorus. For freshwater rotifer, the optimum salinity for the rotifer to survive and reproduce is at 0 PSU. Other than that, B. calyciflorus decreases its survival as the salinity rises. This obviously shown that the species diversity and development of freshwater biota is decreased as salinity increases. Next, the impact of salinity changes on marine rotifer shows that it can endure salinities varying from 1% to 97%. Also, rapid changes in temperature and salinity will affect the rotifer's swimming activity and energy expenditure. Marine rotifers cannot survive at salinity 0 PSU because the best optimum salinities for marine rotifer culture is between 10 PSU to 25 PSU. Various mechanisms have been proposed to explain the poor survival of freshwater rotifers to salt stress. Many physiological mechanisms are involved in the lower salinity tolerance of freshwater rotifers, which entails failure of osmoregulation, reduced swimming rate, and possible reason for the low salinity tolerance of B. calyciflorus could be due to any of the above factors. As a conclusion, the objectives of the study are achieved. Freshwater rotifer, known as B. calyciflorus, is an ideal live food source for freshwater and marine fishes at larval stages due of its smaller size, slow mobility, and easy catchability by the larva. Next, increased in salinity reduces the acclimatization of freshwater rotifer as it can only tolerate with less salinity and be able to survive at 0 PSU. By comparison, marine rotifer, it can survive at the best optimum salinity between 10 to 25 PSU. Last but not least, B. calyciflorus facing difficulties to acclimatize in higher salinity because freshwater organisms really have a very low salinity tolerance. That's all from me. Thank you.